Yesterday we did factoring, and the only thing we did with factoring was what? Take out the greatest common factor, right? We did GCF. Every single time you guys get a factoring problem, you need to say to yourself, okay, is there a greatest common factor? Now today, I'm sure you guys are going to say, oh my gosh, this is so easy, which is good. I want you to say that. We need to practice each different type. So when you're given a problem that just says factor completely, you know what to do. So the first thing we're going to do is always ask ourselves, is there a greatest common factor? Okay. Right now, there's not going to be. We're just going to factor what's called factoring a trinomial, 3 terms, where a equals 1. When I say that, guys, your quadratic is in standard form if it's written like this. Okay? That's standard form of a quadratic. You know it's a quadratic because x is squared, but you have ax squared plus bx plus c. When we say that a equals 1, that means the number in front of x squared is just 1. Now, if you want to go through here and make all of your letters x, that's fine. If you don't want to use p or n or whatever. Now, I know there are some tricks. You guys may have been taught the tricks. We're going to go through the process of doing this, and I will show you the tricks and kind of how you can check yourself, but I would not try and rely on a trick, okay? When you factor a trinomial, you're going to break it down into what we call 2 binomials, 2 parentheses, okay? Now, we are going to factor where a is not 1 later, but not today. But I want you guys to get into the habit of saying, okay, there's a 1 here. If I don't see a 1, I know there's 1 there. So you're going to multiply a times c. You guys remember this? 1 times 48. What are the factors of 48 that multiply to give you a 48, but add to give you 14? 8 and 6, okay? If you don't know the factors, write them out. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So I'm going to put a P in the front of each of my parentheses. And you guys told me 6 and 8. Doesn't matter where you put the 6, where you put the 8. Now you got to figure out the signs. I need a positive 48 when I multiply and a positive 14 when I add, so they're both going to be positive. Everybody with me? So if I was going to check to make sure that I was right, how could I do that? Just distribute. You can just FOIL it. P times P is P squared. P times 8 is 8P. 6 times P is 6P. And 6 times 8 is 14. And combine like terms, right? Okay, so let's go through these. Let's do these together. That's it. 1 times 16. What are the factors of 16 that are going to multiply to give me 16? But add to give me 10. 8 and 2, okay? What are my signs? Both positive, because I need a positive 16 when I multiply and a positive 8 when I add. All right? If you guys don't see that right off the bat, then write out the factors. Write out 16 and say, okay, it's 1 and 16, 2 and 8, 4 and 4. What combination can multiply to give me 16 but add to give me 10? That's where we got the 2 and 8 from. All right, scoot along. 8 times C. So set this up. Put your P in front. 1 times 40. What are the factors of 40 that multiply to give me 40, but add to give me 14? 8 and 5? What's 8 and 5? Give me. 13. What'd you get?
10 and 4.
10 and 4. Perfect. Plus 10 and plus 4. Again, factors of 40, guys. 1 and 40, 2 and 20, 4 and 10, 5 and 8. So which combination will give you a 14 when you add? And it would be our 4 and 10. All right, scoot over here. Get your binomials set up, R and R. Factors of 18 that multiply to give me 18 but add to give me 9.
6.
Good. Positive 6, positive 3. All right. How's this one a little different? There's a negative, okay. We have to do a little bit of thinking, no worries, but get your binomial set up. What are the factors of 7 that give me a positive 7 when I multiply, but a negative 8? Good. Negative 7, negative 1. Let's look at 6. I need factors of 14 that multiply to give me a 14 positive, but add to give me a negative 9. Good. Negative 7, negative 2. Very good. Now, how would you check that? You can FOIL it back out. Say negative 7 times negative 2 is positive 14. Negative 7 and a negative 2 gives me a negative 9 when I add. So there you go. All right. Put your B's in front. 1 times 15. What are the factors of 15 that multiply to give me 15? Positive. But add to give me negative 8. Negative 5, negative 3. Negative 3, negative 5. Perfect. Perfect, perfect, perfect. Let's look at 8. Factors of 63 that multiply to give me 63 positive, but add to give me a negative 16. Good. Negative 9, negative 7. Has anybody noticed anything?
Probably going to be negative if the B is
What do you notice that the last term is in all 8 of these examples? Positive. And what do you notice that the signs inside of your parentheses are in all of the examples? They're not all negative, but they're all what?
positive or negative?
They're either all positive or all negative. They're the same. If you have a positive last term, if your constant, your C is positive, whatever the middle term is, whatever that middle sign is, it'll be in both parentheses. That'll happen every time. If you have a plus end term, if you have a positive constant at the end, whatever the middle sign is will go in both parentheses. Okay, that's the little trick. Now, if I go here, I notice that my end term is negative. That means my signs are going to be what? Nope. They're going to be one negative, one positive. They're going to be different. And there's a trick to figure out which one that is too. And we'll talk about that in a second. I'd rather you just get the factors correct, but if you need to rely on the trick, that's okay. What are the factors of negative 60? That'll multiply to give me a negative 60, but add to give me negative 4, right? Sometimes this is hard. So if I write out factors of 60, 1 and 60, 2 and 30, 3 and, 20, 4 and 15, 5 and 12, and 6 and 10. All right, don't even worry about the signs right now. Let's just figure out which combination can I somehow add or subtract or something to get a 4 or a negative 4. 10 and 6, right? Now I think, okay, well, I need a negative 4 when I add, so which factor needs to be negative?
10.
The 10. Okay, good. And then positive 6. We'll see if you guys can figure the trick out here in a second. Let's go for a second. 10. I have M and M. A times C, 1 times negative 6. So factors of negative 6 that multiply to give me a negative 6, but add to give me a positive 1. What are the factors of 6? 1 and 6, and what else? 2 and 3. So I have a 2 and a 3. Where does the plus sign need to go if I'm going to have a positive 1 in the middle? God bless you.
Thank you. Negative 2.
Negative 2 and positive 3. How can I check to make sure that I'm correct? You can FOIL it. Good. Okay. Next one. God bless. Negative 15. Factors of negative 15 that multiply to give me a negative 15 but add to give me a negative 2. What are factors of 15? 5 and 3. All right. Which one needs to be negative? Got to be the 5. Good. I need a negative 2. So a negative 5 plus 2. Sorry, negative 5 plus 3 is negative 2. All right. Let's look at the last one. Then we'll talk about the trick. R and R. 1 and negative 20. So what are the factors of negative 20 that multiply to give me negative 20, but add to give me a positive 1? What kind of 4? What kind of 5?
4.
Negative 4, positive 5. Does anybody see or know the trick? Say that again.
Like, when it says r squared plus, like the plus is going to be negative. Is it that the, oh, never mind.
Tell me.
The bigger number is always going to be negative.
The bigger number, yes, there is something to do with the bigger number.
Is it that the bigger number is always negative?
Not always.
The bigger number is going to be whatever the middle sign is.
Yes, very good. Okay, look at when you have a minus at the end. You guys see how here we have a minus 6. We have a minus 20, right? If you have a minus at the end, when we have a plus at the end, both the signs are going to be the same as the middle, right? Well, when you have a minus at the end, you know they're going to be different. So the bigger factor gets the middle sign. The bigger factor gets the middle sign. Which one's bigger, 3 or 2?
3.
That's why it got the middle sign of plus.
So
Which one's bigger here, 5 or 4? 5 gets the middle sign. Say it again. This sign right here.
Oh, okay.
So like, do you see here how we have a negative 15? That means I'm going to have opposite signs in my parentheses. The bigger factor gets this middle sign.
So then what about the one above?
Okay, I have a number 9.
Yeah.
Okay, it's a negative 60. That means you're going to have opposite signs, right? So the bigger number, which is 10, gets the middle sign.
Oh, yeah.
Is it always going to be like that?
It is, but it's always, I don't know. I just get confused sometimes when I try and remember it. I just would rather go, okay, I need a negative 4. Do I need negative 10 plus 6 or negative 6 plus 10? To me, that's just easier. But let's go down to these bottom ones, all right? On your test, when we go to have this, I'm not going to tell you factor by doing this. Okay, David, this next one I want you to factor by grouping. All right, Chloe, the next one I want you to take out the GCF. I'm not going to do that. I'm going to say factor completely. So this is where we have to think, okay, is there a GCF? Is there a trinomial that I can break down? Is there a difference of perfect squares? All those questions that you need to ask yourself are going to come up. That's why we're doing each of these one day at a time to kind of just refresh our memory. When I come to this question, all right, anybody, we would have to say A times C, 3 times 30 is 90. What are the factors of 90 that multiply? Okay, if you can make your problem smaller, do so. What do you notice goes into both all of 3, 21, and 30? 3, there's a GCF, right? So if you divide out that GCF, it does not go away. It just comes out in front. And then we're left with our 2 parentheses. Well, we'll break it down in a second. Hang on. I'm left with r squared plus 7r, right? Plus 10. Agreed? Mm-hmm. Okay, so now 1 times 10. What are the factors of 10 that multiply to give me 10 but add to give me 7? R plus 5, R plus 2. But guys, that 3 has to stay in front. Has to. If you don't put it there, your answer is wrong because it does not say r squared plus 7r plus 10 right next to number 13. It says 3r squared plus 21 plus 30. When we factor, we're just breaking down into the simplest pieces, but we're not changing the value. So it's still 3 times r plus 5 times r plus 2. Everybody see that? So get in the habit. When you start to factor, what's the GCF? Is there a GCF? Take it out if you can't. Yes, ma'am.
Would you just leave it like that? You wouldn't distribute or anything?
No, good question. Somebody asked that last period. Do you distribute? If I distributed, I'd come back to my original problem. So when you factor, you're trying to break down into the simplest form possible. So that is as small as you can get it. Okay. So here, 14. What's the GCF? 2. I'm going to bring that 2 out in front. I'm going to divide everything by 2. And that leaves me with p squared plus 7p, right? Plus 12. All right, well, if I break that down, I have p's in the front because my a term is 1, so I'm just going to say 1 times 12. What are the factors of 12 that multiply to give me 12, but add to give me 7? 4 and 3. Good. What are the signs for both of them? Perfect. Good. How many of you like factoring?
Now I understand.
I don't like it, but I don't mind it.
Okay. kind of ambivalent about it? Sometimes it's fun. It's like a puzzle, so it's not that horrible. All right, first question we ask ourselves when we're factoring is, first question you ask, always, is there a GCF? Good. Look, between 2r squared, negative 16r, and 30, is there a GCF? Yes. What is it? 2. So divide out the 2, and I'm left with r squared minus what? 8r. Good. Then what? Plus 15. Perfect. So now I have to factor. I got to break this down even more. I have r and r. What are the factors of positive 15 that multiply to give me a 15, but add to give me a negative 8? What kind of 5? What kind of 3? You're right.
Negative.
Perfect. Negative 5. All right, let's just put positive 3 for a second. Because we're gonna run into this. This is how you check, guys. Check. Negative 5 times positive 3. I'm looking for a positive 15. Does negative 5 times negative 5 times positive 3 give me a positive 15? No. What would give me a positive when I multiply but a negative when I add? Both negative, right? So before you just go on to the next one, just take a second to check. Just to see, hey, did I do this right? Because it's great if you get the correct factors, but if you don't get the signs right, then it's kind of defeating the whole purpose. GCF between 3n squared minus 9n plus 6. 3, good. So take out the 3. I have n squared minus 3n plus 2. Agreed? Okay. What are the factors of 2 that will multiply to give me a positive 2, but add to give me a negative 3? What are the factors of 2? 1 and 2. Okay. 1 and 2. So the only options I have. So what are my signs? Negative and negative. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. Good. Sure. Negative 1 times negative 2 is 2. Oh, okay. And negative 1 plus negative 2 is negative 3. GCF. 3. Good. So take out that 3. I have b squared minus b minus 12. Agreed? Okay. What are the factors of 12, negative, that'll multiply to give me a negative 12, but add to give me a negative 1. Excuse me, a negative 1. What kind of 4, what kind of 3? Perfect. Negative 4, positive 3. And now just for planning purposes, or for an example, change this last one to negative 2n squared minus 2n plus 12. What would I take out here? What kind of a 2 would I take out? Negative. Let me show you why this is so important, guys. If you lead with a negative, you have to take it out, because if you don't, then you will not be able to factor completely. If I take out my negative 2 here, I have negative 2 on the outside, then I'm left with n squared. What's a negative divided by a negative? Positive n, and then 12 divided by negative 2 is minus 6, right? Now I have the factors of negative 6. Multiply to give me a negative 6, but add to give me 1. What are my factors of 6? 2 and 3, good. 2 and 3. I have same signs or different signs? They'll be different. So the bigger number gets that middle sign. Middle number? The bigger number gets the middle sign.
3.
Yeah. Again, if you mess up, if you switch your signs, just FOIL it back and make sure that you are correct. If it doesn't work out, then you know that your signs are incorrect. All right, let's look at this. What do you guys notice about these? How are these different? This first 2. They're smaller. So they have less terms. There's only 2 terms, right? So sometimes when you're factoring, you come up to something and you're like, okay, well, this is different. So you have to kind of see if you notice anything, guys. Is there a GCF in number 1? Is there a greatest common factor? No. All right, it's not a trinomial. I can't break it up like that. What times what's going to give me? But what do you notice about 16 and 9? They're both perfect squares, yes? What do you notice about the sign in the middle? It's negative. If you come to a binomial, right? I have 2 terms. If you come to a binomial and it has a minus sign in the middle and a perfect square in the front and back, this is called the difference of perfect squares. All right? This is how I teach my students to do it. What is the square root of 16? What times what gives me 16? 4 and 4, yes? What times what gives me n squared? N, right? What times what gives me 9? 3 and 3. So there's your 2 parentheses. Each parenthesis is going to have a 4n in the front and a 3 in the back. And if it's the difference of perfect squares, are the signs going to be the same or different? Different. That's why it's called the difference. Difference, there's a minus sign in the middle. That's how you can remember that. Difference, there's a minus sign in between 2 perfect squares. When we FOIL this out, guys, okay, here's my answer. When I FOIL this out, what's 4n times 4n? 16n squared. What's 4n times negative 3? Negative 12n. What's 3 times 4n? Plus 12n. What's negative 3 and a positive 3? Negative 9. What happens to my n's in the middle? They cancel. That's why the signs are different, because when you FOIL it out, the middle term cancels. So look at 2. Is there a GCF in 2? No. Do you notice anything about 4m squared and 25? They're both perfect squares. Is there a minus sign in between them? Okay, perfect. So what's going to go in the front of each of these parentheses? 2m, good. And what's going to go in the back? 5 and 5. And what are my signs? Different. Plus minus. Minus plus, however you want to do it. Good.
Wait, why are they different?
So when you FOIL it out, the middle terms will cancel out.
Okay.
It's always like that when it's difference of perfect squares. All right, what do you guys notice here? It's a trinomial. Now, we're going to talk about factoring where A is not 1. This would be the case. The way we would do it, you don't have to write this down. You'd say 16 times 25. Ooh, what is 16 times 25? Something big, right? And then I have to figure out 16 times 25. What are the factors of that number that would add to give me negative 40, right? This would take you a long time. Do you guys notice anything about the beginning term and the ending term? They're both perfect squares. If you have a trinomial that the first term and the last term are perfect squares, this is called a perfect square trinomial. This helps you guys out a ton if you can see this pattern. What times what gives me 16b squared? 4b, right? What times what gives me 25? 5 and 5. So what are your 2 parentheses going to have in the front and in the back? 4b in the front and 5 in the back. Now, I don't want my signs to be different, because if they were different, then the middle terms would cancel out. We don't want that. Whatever the sign in the middle is, goes inside of your parentheses. This can also be written, guys, as 4b minus 5 quantity squared. If you notice, right, the first 2 we did were the difference of perfect squares. There's only 2 terms. The reason there's only 2 terms is because when the signs are different in the parentheses, the middle term cancels out. When you have, when you have a trinomial, there's a middle term. So the reason that in that case your sign is the same in both the parentheses. If we FOILed this out, what's 4b times 4b? 16b squared, right? What's 4b times negative 5? Minus 20b. What's negative 5 times 4? Minus 20b. What's negative 5 times negative 5? Plus 25. So do you see here, instead of the middle terms canceling out, they actually double. And that's why we come back to a trinomial, and it's not a binomial. It's not 2 terms, it's 3.
Why doesn't it cancel out?
Because if the signs are the same, look, negative 5 times 4b is negative 20, and then 4b times negative 5 is negative 20. So you have negative 20 and negative 20 gives you negative 40. So if I look here, is 4x squared a perfect square? Yes. Is 1 a perfect square? What times what gives you 1? 1. Okay, so break this down. What times what gives me 4x squared? 2x and 2x. What times what gives me 1? 1 and 1. This is a trinomial. That means my middle signs are going to be the same. So I have a 2x in the front of each. I have a 1 at the end. And what's the middle sign in both of them? Negative. Minus the negative, whatever sign's in the middle. Good. Another way you can write that is 2x minus 1 quantity squared. Same thing. Is this a perfect square trinomial or a binomial? Meaning the signs in the parentheses are going to be different. Very good, guys. What are my parentheses going to look like? 3x minus 1 and? Perfect. Good. Trinomial, binomial? Bi. That means my parentheses are going to have the same terms, but what kind of signs? Different. What's the parentheses look like? N plus 5, just n, not n squared. N plus 5, n minus 5. Ooh, tricky. Is n to the 4th a perfect square? Yeah. What times what gives me n to the 4th? N squared, n squared. Good. So n squared, n squared. What times what gives me 100? 10 and 10. Since this is the difference of perfect squares, what are the signs in the middle? Negative and positive. 1 plus, 1 minus. Talk through it. Are there 2 terms? Yes. Or 3 terms? 2. So what do you know about the signs when there's the difference of perfect squares?
They're different.
They are different. Perfect. What times what gives me a to the 4th power?
A squared.
A squared. Perfect. And what times what gives me 9?
3.
3 and 3. Awesome. Perfect.
Okay, got it. And then if it's a trinomial and they're perfect squares, then they have to be the same.
Correct. Same sign. Whatever's in the middle. Like that one.
Okay, got it.
Good. All right. What is 9? Tell me what 9, my 2 parentheses look like. K squared minus 6. K squared plus 6. Awesome, guys. What about 10?
N squared.
N squared minus 7 and?
7.
Perfect. Good. We done with that whole page? Okay, great. Next page. Woo! Whoa. Now all of a sudden, here you go, Mrs. Meadows. Geez, we're just doing a good job, and then what? All right, what is the first question you ask yourself every time you're going to factor? Is there a GCF? Is there a letter or a number that they have in common here? 2. Let's take out the 2. So I take out the 2. What's 98 divided by 2? 49. N squared. Minus, what's 200 divided by 2? 100. All right. Do you guys notice anything about that? They're both perfect squares, aren't they? So I have 2, and then what do my 2 parentheses look like?
7.
Good. Be confident. 7 what? 7n. Minus 10 and Perfect. Good. Good. Tell you what, when you recognize that GCF, it makes things a lot easier, I promise. I would rewrite this. It looks weird if we don't. I'm going to write x. 3x squared plus 6x plus 3. Is there a, yes, sir?
Take out 3.
Okay, take out the 3. I have x squared plus what? 2x plus 1.
And then that what's in the parentheses, that's going to factor out to x plus 1 times x plus 1.
Perfect. Just a normal trinomial, but is x squared a perfect square? Yeah. Is 1 a perfect square? Yeah. So there you go. Very good. You guys are going to get the hang of this, I promise. Let's rewrite this. Negative 36, I'm going to use the x squared plus 400. First of all, it's leading with a what?
Perfect square.
It is a perfect square, but it's leading with what kind of a number? Negative. I don't like that. So I'm going to divide out a negative 1. When I bring that negative 1 out, watch what happens. Because right now, guys, negative 36x squared plus 400, that's not the difference of perfect squares. Because it's not a minus sign in the middle. Now, when I rewrite this as 36x squared minus 400, with my negative out in front, is this now the difference of perfect squares?
It has to have a negative in order to be a difference of perfect squares.
Correct. Has to have the negative in the middle. Good. What's the perfect square of 36? 6x and 6x. Good. What about 400? 20. What are the signs? Plus and minus. Okay. What do you guys notice about these parentheses?
That you could factor out another 2.
You can factor out another 2. Right? What should we ask ourselves at the very beginning? I did this on purpose. What should we ask ourselves at the very beginning when we're working these problems out? Why is this so tiny?
Jeez.
Is there a what?
Yeah.
You can make it bigger.
Oh, what am I doing here? Here? And now my eraser's bigger? Nope. It's okay. Okay, so let's look at this again. Right? I want you guys to take out the GCF. We've got to get in the habit of always taking out a GCF. I was going to see if anybody caught it, but that's okay. Is there a GCF between 36 and 400?
That would be a 9 and then that would be
Right? Does 4 go into 36? Yeah. Does 4 go into 400? Yeah, so let's take out a negative 4. So if I bring that negative 4 out in front, this becomes 9x squared minus what? 100. Is that a much easier problem to deal with? Does that just jump out at you? You guys like, oh, I see, 3 and 10. If you take out the GCF at the very beginning, it not only makes your problem a little easier to deal with, but it's easier to look at. Make sure, guys, when you write your answer, that negative 4 has to stay in front of your answer. If you just have 3x plus 10, 3x minus 10, and that's what you circled, I would not give you full credit. You have to have that GCF out in front. Yes, sir. All right, let's look at 14. Whoa. Oh my gosh, these numbers are ginormous. Right, look, if you don't recognize and you say, okay, A times C, then you have to find the factors, ladies and gentlemen, the factors of 8,100. Okay, some of you don't even want to write out the factors of 12. But if you had to write out the factors of 8,100 and figure out what would multiply to give you 8,100 but add to give you 180, you guys don't want to do that. So if you can recognize these perfect squares, it's a really good thing to do. You should, when you see 100, you should think what? 10 times 10. When you see 81, you should think what? 9 times 9. So this would be 10x and 9, 10x and 9. What are my signs going to be? Is this the difference of perfect squares? No. So what should my signs be? The same. It gets that middle sign in both parentheses. You can write it out like this as well. Remember, if you have a perfect square trinomial, your signs are the same. All right, what do you notice right off the bat here? I don't see a perfect square. What do I see? You can take out what?
10.
Good. Take out the 10. When I take out the 10, I'm left with n squared. What? Plus 10n plus 25. Perfect squares?
Yes.
Yeah. 10's on the outside. N's in the front of each parenthesis. What's in the back? 5. And then what's my middle sign? Both plus. Good. Again, you can rewrite it as n plus 5 quantity squared. We're going to get all of your homework done. How nice is that? Well, almost all. All right. GCF? No. So then you're like, oh, 49 times 6. Oh my gosh. Wait a second. What do you notice? What's perfect squares? First n. Good. So what's the first term in each parenthesis? 7n. Good. What is the second term in each parenthesis? 4 and 4. Good. What are the signs? Negative, negative. How else can I write that so it looks a little more grown up? 7n minus 4 squared. Quantity squared. Good.
But on the test, we can write it how.
Yeah, you can write it like that. 17, tell me.
7
They are perfect squares. Good. So 7x minus 10 plus 10. It's the difference of perfect squares. Two terms, negative in the middle. Ugh, what do we think about this one? It's gross. Let's rewrite it. Good. So negative r squared plus 1. Let's take that negative out. Negative 1 out in front gives me r squared minus 1. Is r squared a perfect square? Yeah. Is negative 1 a perfect square? Or is 1 a perfect square? Sure is. So my parentheses are r plus 1, r minus 1, and that negative stays out in front with it. You guys are doing a good job. All right. Ay, ay, ay. These numbers are ginormous. I don't see a perfect square. I don't see anything raised to the second power. What's the first thing we look for? 10 what?
190.
Good. We can take out 10p. When we take out 10p, we're left with p squared minus 196. Do you guys think 196 is a perfect square? Yeah. It is. Do you know what the square root of 196 is? 14. It would be helpful if you guys knew your perfect squares up through 20. So it'd be plus 14 and minus 14. But remember, that 10p has to stay in front, because if it doesn't, then it's not the same equivalent to your original problem. Mm-hmm. Whoa. There's a lot going on here. First of all, how should I rewrite this? Standard form. So I'm going to say negative 7b to the fourth plus 343. Agreed? Okay. So now I'm going to say, all right, what do they have in common? Well, first of all, I see, oh, I forgot b's. You're right. I forgot. Thank you. Thank you. I noticed, guys, that they have b's in common. But what else do you think they probably have in common? Maybe a 7. All right, if I take out a negative 7b squared, I'm left with b squared. Does anybody know what 343 divided by 7 is? 49. If I divide out a negative 7, that's going to leave me with a negative 49. Much easier problem for us to deal with now. What's my answer? Negative 7b squared, then what are my parentheses?
B plus 7 and B minus.
Perfect. B plus 7, B minus 7. Good job. Wowza. What do they have in common?
9.
Definitely have V's in common, right? And a 9. Okay, I'm going to take out 9v squared. 9v squared, 9v squared. Well, when I do that, I'm left with 9v squared minus 100. Well, look at that. Difference of perfect squares, right? So 9v squared. And then what are my parentheses? 3v minus 10n. Perfect. All right, lastly. Oy, oy, oy. You're going to get problems like this, guys, and you're going to just be like, oy, what do I do? What's the first thing you ask yourself? Is there a greatest common factor? Is there a number that goes into 200, 80, and 8?
8 doesn't go into 200, does it?
What is it? 8m squared. Okay, 8m squared. What's 200 divided by 8?
25. Oh wait, what was the question? 200 divided by 8?
What's 200 divided by 8? Okay, so 25m squared. What's 80 divided by m squared? 8m squared. So plus 10 what? M. And then what? Plus 1, right? Is this a perfect square trinomial? Yeah. Is 1 a perfect square, guys? Yes. It's the easiest one for us to know. Don't confuse that. What's a square root, or what times what is 25? So 5m, 5m. What times what is 1? 1n, 1. What are my signs? Plus, plus. Awesome. And ladies and gentlemen, your homework is done.